Hey guys, so we're back again today and we're talking about volume, specifically volume of cones and pyramids. So if we remember back to our example in class that we did, our little presentation, we can remember we had a cylinder with a circular base. And then we took our cone with the same circular base, and we saw that if these bases are the same, this cone will fit perfectly inside this cylinder. Okay? And the bases are the same, so they'll be the same up here too. And then we remember we took our cone, we filled it with water, and we poured it inside this cylinder, and it reached to about here. We took another cone full, and we poured it in, and it reached about there. Finally, we put one more in, and it reached all the way to the top. So then, we knew that 3 cones of water equaled 1 cylinder. Another way to say this would be to say that 1/3 of a cylinder equals 1 cone. Because remember, 3 divided by 3, that's just going to be 1. So 1 cone equals 1/3 of a cylinder. And cylinder is our home base for finding volume. We remember in our last video that we saw the volume of a cylinder is going to be pi r squared times h, because it goes back to our volume equation of length times width times height equaling volume. So if we take that and we say pi r squared times height is going to equal the volume of this cylinder, but we know that we don't want to find the volume of this cylinder, we want to find the volume of this cone. This cone is 1/3 of the cylinder. So we can just take the volume of the cylinder, multiply it by 1/3, that will equal our volume of a cone. We brought down this 1/3 of a cylinder is going to equal 1 cone, so we multiplied our equation for the volume of a cylinder by 1/3. Now, we also remember that we did the same thing with a cube. So we had our cube there. Ooh, this is going to get kind of messy. And we took a pyramid that had the same base. And let me try my best to draw this here. Okay, well, you get the idea. These bases are the same. So when we put this pyramid, flip it upside down, put it in the top here, the peak will reach right there at the very bottom. These bases are the same, so they're going to line up perfectly. And just like with our cones, it'll take 3 pyramids to equal 1 cube. And just like with our cones, we can say that the same way by saying that 1/3 of a cube equals 1 pyramid. And then we can remember that to find volume, remember, volume, length times width times height for rectangles. This is just a rectangle. So we can take our length times our width times our height. So we can say this is length, this is width, this is height, just for this example. We can take our length times our width times our height. But we're not looking for the volume of this square, we're looking for the volume of this pyramid. And since this pyramid is 1/3 of this square, we multiply it by 1/3. That will give you our volume of a pyramid. And you can do this for anything that has a base that's going to equal the base of this unit here that has the same faces are our cylinders, remember. It's just got this pointed top here. As long as these bases are the same, you can stuff it in there. It's always going to equal a third. Then you can just use your length times width times height equation. That's going to give you the volume of this pyramid or cone.